go. All right. Okay. So again, we want to find an equation for this graph, for the function here that's graphed. Now I did give it away already, but the vertex is, as you can see, -4, 1, right? Again, the vertex is where the graph changes direction. So again, if you imagine yourself walking along the graph, right, like walking on a trail, notice how we change direction at the vertex, at this point, right? And then we walk down like this. So this is the vertex. And again, this is the vertex, right? So that tells us HK is -4, 1. -4, 1. So H is -4, K is 1. It follows then that y equals, right? This is our formula that the function must take. We're using this just like in the other examples. So what we get then is y is a times x minus -4 squared plus 1. And so we get this. Minus the negative is plus. So we know the function has to, an equation for this function graph has to look something like this. Y equals this. But are we done? Not quite. Well, we got to figure out what A is. But we know it passes through a few different points. For instance, this point over here, 6, 0, it passes through there. I mean, you should be able to see that each of these little dashes is 1 unit, right? I mean, this is -5 over 1, -4. And also you could do this, -5, -4, -3, -2, -1, 0. So it should be easy to see that each line here is 1 unit. Each box, that is, that's better to say. All right. So we have it passes through -6, 0, what is that? -2, 0, and 0, -3. So I'm going to use this point, but again, that's kind of arbitrary. You can use any of these 3 points. I mean, you really could use any point that the graph passes through. I mean, I just wrote these 3 because one of the coordinates is 0, so I think that would make it a little bit easier. Okay, so we have 0, -3, right? -3 then is y. So when x is 0, y must be -3. That's what this is telling us. So when x is 0, right, we must get -3. Okay, so we know this equation must hold. Well, let's see what A is. We get A times 4 squared plus 1, which is 16A plus 1. So we have this equation now, like so. Okay, subtract 1 from each side, right? We get -4 is 16A. Right, that's what we get. You know, we subtract 1, we want to get A all alone. So we divide by 16. Then we get -4 over 16 is A. Right, we divided by 16. I rewrote it as -1 over 4. Again, if you left it as -4 over 16, that's fine. So we get A is -1 over 4, and that's our function. This is our function. This is our equation, excuse me. Okay, good. Okay, any questions on this? Sorry, not there yet. Okay, So I also wanted to go through one of these kinds of examples where you have a system of equations. I thought it would be good to go through this. So here, I'm going to solve it using elimination. Again, unless I tell you to use a certain method, you can use any method you want. Okay. I mean, I actually show later on, as you probably saw in the notes already that I sent you, I'm also going to solve this using substitution. Of course, you only need to do one method. So from here, right, with elimination, we want to somehow eliminate a variable by adding the equations, possibly multiplying an equation by a number if necessary as well. Now, looking at the x's alone, we have a half here, we have 2, right? But we know if we multiply a half by -4, we're going to get -2. So that tells us alone that we should multiply the first equation by -4 and add it to the second. So again, you can almost imagine it this way. If we just had 1/2 x and 2x, and you wanted to add to get 0, well, if we multiply the first here by -4, this will become -2, and then if we add, x would go away. And that's what I'm doing here. I mean, you could work with 2y and -3y if you want to, but you would have to multiply both equations by something. I mean, that's not wrong. It's just a different way of approaching it. You know, the whole idea is you want to get rid of one of the variables. You know, why deal with 2 when you can get away with dealing at 1, if that makes sense? Okay. Now, so we multiply by -4, right? We get -4 times 1/2 times x -4 times 2y. Again, I'm multiplying both sides by -4. I distribute. Here, let me draw that. Okay, so again, what do? I distribute like so. We get this. We get the line under it. We get this thing. We get -4 times 1/2 times x -4 times 2y is -4 times 9. What does that equal? Well, this becomes -2x, right? This becomes -8y. This is -36. So now our system is this. This is what we're dealing with. But now you can see it's a lot. If we add the two equations, okay, what's going to happen is the x's will cancel. And so we get this. That's what we get. So we get 11y when we add is -22. Okay, that's good. And so we have -11y, the x's are gone, equals -22. So how do we get y? Well, we divide by -11. That's what we're doing. And we get y is 2. We have one variable done. What about the other variable x? Again, we can use either equation. So in the original system, we can use either equation. Because of the fraction here, I'm going to use this one. Right? Since y is 2, we can plug it in, as I'm doing here, and solve for x. And these calculations show it. You know, so we get 2x minus 3 times 2 equals 14. I replace y by 2. Okay? Then we solve for x. And that's what I'm doing, as you can see. And we end up getting the only solution is 10, 2. That's what we end up getting. Oh, no, that's different. Okay. All right. Are there questions about that? Because we're out of time, so we'll finish this on Monday, and then we'll do some more examples. Okay, so if I don't hear from you before then, I do have office hours today.